Today we're going to be working on our binomial variable text sheet. So we are going to be creating a binomial variable distribution. That is to say that, hey, we are going to be working on this particular one right here. So that being said, we have recently learned that if there are two outcomes, right, binomial two, labeled as either a success or failure, that we classify these as a binomial random variable. So unlike before, where we had lots of different countable occurrences, we now only want to label our favorable and unfavorable outcomes as a success P or a failure Q. Realistically, we can think of a quality management. So either a product falls between a certain range and is therefore not defective, successful, or it falls out of the range where it's labeled as a defective value or defective piece, and therefore it's a failure. You can use binomial distribution to calculate the probability of finding a certain number R or X of defective items in the sample. And this helps decide if a production batch needs further inspection or adjustments. So that's kind of like a quick idea of, hey, this is what you could be seeing in the future. So throughout our studies, we have now come to put bigger equations and ideas together, such as the equation that we see for your binomial random variable. So that is this choose feature, that is your binomial variable probability. So these things are coming together. So it says we're going to be working from example 2 of our guided notes, where we talked about selecting somebody that was 65 years or older from a sample. So it says X is the outcome of a resident is 65 years or older. The probability of that occurring is about 20%. And it is all just from here. So that's the information that we're working with. So we know that, okay, of your sample, there's 6 people being sampled. I think it's, 6 sampled. Your P, they just told us, was 20%. They also said that in the future, right, we're hoping that of your sample of 6, that exactly 4 of them will be 65 years or older. So we'll use the 4 right here. Now, in order to get Q, right, it says B4 by negating, it should say negating B3, not negative B3. So it says 1 minus. So B3 being here, right, we want to take the opposite. So that's why we should have your 0.8 here. So when we're asked to find a specific value, hey, I want, of my total 6, I want to hope that I select 4 of them to be 65 or older from my set. So when it's a specific, right, we can in fact use your choose factor, right, and this equation. But Excel is really nice because it has a built-in feature. It's called your binomial distribution. So it says in cell B6, we want the probability of specific values such as exactly 3 defective or exactly number of residents, right? So it says equals binomial or binom dist. And you'll notice that there's a few of them. We're going to be working with binomial distribution. So when it says S, and it tells you what you're trying to do. So number of S, this is referring to the number of successes. So for us, that would be in B5. Hey, I'm hoping that 4 residents that are selected are successful in being my 65 or older. So comma, and then it says trials. So trials is your total. So 6, B2, comma, the probability of S, so the probability of success that is found in B3, comma, and then because it says cumulative means, hey, are we going to tally up all of the values that are lower than 4 and 4, or do we want something that is very specific? So for us, we do not want cumulative, we do not want a range, so we are going to be using false. Go ahead and hit enter. And as you can see here, for us, in order to get exactly 4 residents to be 65 or older, that's about 1.5%. We have seen that value before. That is right here. Now, what's nice is that once you have set this up the first time, if you wanted to tally, okay, that somebody is that you don't select any. So by selecting 0, notice that that changes right away. So that's how you get to see this 0.262 value. And again, if you're selecting 1. But if you go on to some sort of take where it says, okay, well, maybe we want to do a range, right? When x is greater than or equal to 2, right? So therefore, we highlighted, okay, all of these. So if you were interested in making a probability distribution, by all means, we can do that. However, we also can have this sort of range, which I'm going to pop my sheet back up here. So it says, when we want to find the probability of a range of successes, such as the probability of selecting residents who are 65 years or older, is at least 2. So a minimum of 2 from the sample of 6. So that just means that we go all the way from 2 and we lead all the way to 6. So it says in B5, we should have the lower range. So at least 2 means a minimum of 2. So we're going to change this to have 2. When it says in D5, right, D5, we should have the upper range. Well, where does your sample end? Well, I want to tally up anything from 2 all the way until my values or my sample ends. So 2, 3, 4, 5, 6. Or again, you can do always the opposite. Maybe it was a minimum of 2, right? In which case, sorry, not a minimum, a maximum of 2. So 0, 1, and 2, right? So 0 would be here and 2 would be here. So for us, if we are looking for, where did my range go? Oh, I might need to do that one more time. I'm not sure what happened here. So equals binom dist. There we go. I'm not sure what happened. That it should have come up, but that's okay. This one is really easy to fill in. There we go. I may have hit the wrong maybe Excel sheet. So if we're looking at a range of items, so this is where in D6 we can have your range. So equals binom dist, and this is where you can see that range. So to do the range, it says, okay, the number of trials, so that is in B2, comma, the probability of S, that is in B3, comma, it says the number of S, so that is the lower of your 2 values, so that is found in B5, comma, and then all the way to your higher output, so that is found in D5. So here we should get about 34-ish%. Now, if we were to take a look at what our thing said over here, well, I guess I didn't calculate it, but you can tally up these values and you should get about 34%. And again, I'm just kind of rounding here. But that is exactly what you can do in the future if your problem changes. All you would have to do is, okay, I'm looking for a range. I'm going to be changing these 2 values. Maybe it's from 0 to 2, in which case it's about 90, or from 2 to 3, and there you go. Always your lower range here and your higher range here. And again, you can also do this on your calculator very easily as well. If you don't have a newer calculator, that's okay. You're still going to be pressing the same ones, but you're going to be putting in your N followed by a comma, a P, comma, an X, close parentheses.